Well, remember that the forces have two different kind of effects about the forming objects. Remember, could be an elastic deformation. I pull the rubber band and it deforms, but then it keeps again recovers the original shape, or a peg also it can deform and it returns to the original shape. This was a kind of effect about changing the shape, and most important than this, those changes in motion, changes in motion state. These changes in motion state are investigated through the Newton's laws that you copied in your notebooks. Newton's law, three laws about the motion. The first Newton law, the law of inertia. That means that objects will try to remain in their original state, either if they are at rest with no speed, with speed 0, or either moving at some speed. They'll try to keep this state. If they are in rest, they'll try to keep at rest. If they are moving at constant speed, they'll try to keep in this state. So something is at rest, it will remain at rest unless you make some force, or if it's moving, it will keep moving unless you do some force to stop. So the inertia tells me that objects that are in motion will tend to keep in motion, and objects that are stopped try to keep at rest. If I want to change this state, I want to accelerate something that is stopped, I want it to move, I have to apply a force, and then I get this object moving. The speed changing from 0 to something different from 0. Again, if something is moving and I want to change this motion, I want to stop, for example, then I have to apply a force as well. Something that is moving, if I want to stop the subject, I have to apply a force. Okay, I have to put something here, and to stop I have to apply a force to stop something that is in motion. La primera ley de Newton, ley de inercia. Los objetos tienden a mantener su estado, ya sea de reposo o de movimiento uniforme, con velocidad constante, ¿vale? O bien se quedan en reposo, o bien si están en movimiento van a intentar seguir en movimiento. Si yo quiero cambiar eso, tengo que aplicar una fuerza. Estaban en reposo, quiero que se empiecen a mover, estaban en reposo, quiero que se muevan, tengo que aplicar una fuerza para que empiecen a moverse. Si se estaban moviendo y quiero que se paren, también tengo que aplicar una fuerza. Si algo viene moviéndose y quiero que se pare, tengo que aplicar una fuerza, ¿vale? Primera ley, ley de inercia. Second law, the fundamental principle of dynamics, the law of force also called, and they tell me about the relation between force and acceleration. Remember what acceleration is. Acceleration is the change in speed over time. So if there's a change in speed, a change in speed means there's an acceleration. Recordad que la aceleración significa cambio de velocidad. Así que si hay un cambio de velocidad, es que hay una aceleración. ¿Vale? This means in both cases here there are accelerations. Something that is at rest, speed 0, now is moving with some speed different from 0. So a change in speed. There's some change in speed in here. Also in here, something is moving and I stop it, so there's also a change. In this case was positive, in this case was negative, but a change. ¿Ok? En cualquiera de estos casos, si yo cambio el estado de movimiento, va a haber un cambio de velocidad. ¿Vale? Cambio de velocidad porque pasa de no moverse, de moverse a velocidad 0, a moverse a cierta velocidad, cambio de velocidad, moverse a cierta velocidad distinta de 0, moverse a 0, cambio de velocidad. So, if there's a change in speed, there's an acceleration. And if we want an object to experience some acceleration, we need to apply a force. You see, I want this speed to change I need to apply a force. I need the speed to change. I need to apply a force as well. So there's a relation between acceleration and force. And the relation, the second Newton law, tells me that the relation is that if we apply a greater force, we'll get a greater acceleration. This is quite obvious, isn't it? La segunda ley de Newton me dice que la relación entre fuerza y aceleración, a mayor que sea la fuerza, mayor que será la aceleración. Lógicamente, cuanto más fuerte le dé al objeto que está parado, mayor va a ser la velocidad que adquiera, ¿no? Si le doy un golpe más pequeño, si le doy un golpe más fuerte, voy a conseguir una velocidad menor o mayor. The greater the force, the greater the acceleration. Directly proportional. The one increases, the other also increases. And they tell me also the relation that if the mass is increased, the acceleration that is observed is decreased. The greater the mass, the less the acceleration. This is quite obvious also. If you have two different balls, a tennis ball or a football ball, and you kick them with the same force, you'll observe that the tennis ball will move faster, move with a speed that is greater than that of the football ball. Si tenéis una pelota pequeña y una pelota grande, le dais una patada igual de fuerte, la pelota pequeña se va a mover mucho más rápido que la pelota grande. Si una pelota grande le dais un golpe con la misma fuerza, vais a conseguir que vaya más despacio. O sea, el cambio de velocidad va a ser menor. La aceleración, por tanto, va a ser menor cuanto mayor sea la masa. You push a car. You want to push a car, a tiny car, with some force, and a big car or even a lorry. You can think of a lorry. Okay. If you try to push the car and the lorry with the same force, maybe in this case you will get the car moving with some speed, but maybe you cannot even move the lorry, or if it moves, it will do it slowly, quite slowly, because the mass is much greater than this. Empujáis un coche pequeño, empujáis un camión con la misma fuerza, pues el coche vais a conseguir que se mueva. Sin embargo, el camión o no vais a conseguir que se mueva, se va a mover muy despacio. So, the greater the mass, the less the acceleration. Okay, this could be represented in the one formula that was the influence in the acceleration of force and mass. Like this, we see that an acceleration depends on the force, in the way that if the force increases, the acceleration increases, and if the mass increases, the acceleration decreases. And also, if you get this mass, this side multiplying, you can get also this equation for the second Newton law. ¿Ok? Segunda ley de Newton, que se puede expresar así como una fórmula. La aceleración depende de la fuerza y de la masa. De la fuerza directamente proporcional, la pongo aquí arriba, cuanto mayor sea, mayor va a ser este número. La masa aquí abajo, cuanto mayor sea, más pequeño va a ser ese número. ¿Vale? O también visto de esta manera. Ahora haremos unos problemas con esto, que era lo que quería hacer. And third Newton law, action and reaction. When there's an object exerting a force, the other object exerts an equal force but opposite. You see, two objects. Okay, I'm going to throw this to hit the stone, and we will see that there appear two forces. One of this plastic with the stone, and the other one the stone on the cover. Okay, you see, this is action and reaction. Okay, two forces. You see that in here there is a force acting from the cover on the stone, and the stone moves, it trembles like this, and also force acting on from the stone to the cover that make this rebound to go to the other way, so to change the direction of motion, isn't it? So there are two forces in here. One, that this object exerts on this one in that direction, and also there's a force in this direction that goes the other way. You see, again. Okay, both move. This moves in that direction, there is a force in this direction, and this move in the other direction. Why the difference? Why the difference of behavior? Because of this. This has a greater mass than this, so the effect is more visible in this one that is lighter than in this that is heavier. Principio de acción y reacción. Aparecen dos fuerzas cuando interactúan dos cuerpos en dos direcciones. Este cuerpo sobre este, una fuerza en aquella dirección. Este cuerpo sobre el otro, una fuerza en aquella dirección. ¿Vale? Y están esas dos fuerzas. Ambos sufren la acción. Este se mueve en aquella dirección, poco, y tiembla. Y este rebota en la otra dirección. ¿Vale? La diferencia de efectos tiene que ver con la masa. Esto es mucho más pesado que esto, que el tapón. Por tanto, el efecto aquí es menor, su aceleración es menor que en este. ¿Vale? Pero el efecto es claro, el efecto de acción y reacción. Okay, so third Newton law, action and reaction. But I want to focus on the second Newton law, the fundamental principle of dynamics. And I want you to follow me in doing some exercises here, page 38. These 3 exercises, let's work with them. And using just these 2 formulas of second Newton law. Okay, we're going to work with these formulas. And the first exercise, they tell me how much force will we have to apply to a wardrobe weighing 10 kilograms to make it accelerate by 1.5 meters per square second. So they give me the mass, 10 kilograms, and the acceleration, 1.5 meters per square second. And from here we have to calculate the force. So it's clear, it's this equation. You see, we have just to multiply 10 kilograms times the acceleration, 1.5. Make sure that you use homogeneous units. In this case, these all are international system units. For mass is kilogram, for acceleration is meter per square second. So you have just to multiply, and this is 15. And remember the units for force, that is newtons. So exercise 15, the force is 15 newtons. Me dicen que tengo hoy un armario que pesa 10 kilos y lo quiero mover con una aceleración de 1,5 metros por segundo al cuadrado. ¿Qué fuerza hay que aplicar? Pues bien fácil. La segunda ley de Newton, su forma matemática, lo que me dice es que la fuerza es la masa por aceleración. Pues tengo la masa, tengo la aceleración y multiplico. Simplemente que esté en el sistema internacional. So, the force we need to apply is 15 newtons in this case. Let's go to exercise 16. Now, they ask, what is the acceleration of a body weighing 3.5 kilograms if we apply a force of 14 newtons to it? So, now we have that the mass is 3.5 kilograms. And they tell me we apply a force of 14 newtons. And we have to guess the acceleration. So, now we should apply this formula. Acceleration is force divided by mass. So acceleration will be force 14 newtons divided by mass, that is 3.5. Okay, in this case you divide, this is 8. 8 what? The units for acceleration in international system, that is meters per square second. So here it is. Acceleration 8 meters per square second. Lo mismo, vamos a relacionar fuerza, masa y aceleración. Ahora me piden la aceleración, me dan la masa y la fuerza. Todo lo que hay que hacer, utilizar esta relación. La aceleración es la fuerza entre la masa. Pues ya está. Fuerza de 14 newtons, sistema internacional, masa 3,5 kilogramos, sistema internacional. Y tenemos esa aceleración. 14 de 3,5, 8. And to end with, let's go to exercise 17. We apply a force of 250 newtons to a cement block so that it gains an acceleration of 2 meters per square second. What is the mass of the block? And how much force do we need to apply to double the acceleration? Okay, first, let's calculate the mass. You see now, 17, we need to calculate the mass. They give me the acceleration, that is was 2 meters per square second, and the force, that is 250 newtons. And we do not know the mass. Look at this. We have in here 4 is mass times acceleration. If we want to solve for mass, the acceleration, that is multiplying, goes to the other side dividing. So this goes dividing to the other side, and we have the mass can be calculated like this: force divided by acceleration. A partir de esta fórmula, si lo que quiero es la masa, todo lo que tengo que hacer es despejar. La aceleración estaba multiplicando, pasa dividiendo. Pues ya tenemos. La masa será 250 newtons, que es la fuerza, entre la aceleración, que son 2 metros por segundo al cuadrado. So 125, the unit for mass, that is kilograms. Okay, you can also use this kind of triangle we use for velocity and for acceleration. If you write like this formula like this in the triangle, acceleration, force, and mass, you can see force is mass times acceleration, this one. Acceleration is force divided by mass, this one. Or mass is force divided by acceleration. Mass is force divided by acceleration. So also using this triangle, you can solve this kind of exercises. Calculate the force knowing mass and acceleration, calculating acceleration knowing mass and force, calculating mass knowing force and acceleration. Okay, and the final question is: how much force do we need to apply to the block in order to achieve double the acceleration? So double the acceleration. Remember that acceleration and force are directly proportional. So if one is increased, the other one must be increased in the same rate. So if we multiply this by 2, this also should be multiplied by 2. Directly proportional. This means directly proportional. If we increase by a factor of 2 the acceleration, the force must be increased also by a factor of 2. Aceleración y fuerza son directamente proporcionales. Si me dicen que quiero duplicar la aceleración, multiplicarla por 2, la fuerza también la tengo que multiplicar por 2. ¿Vale? So, the answer for the final question would be: I need a force of double this, 500 newtons. We want to double the acceleration, going from 2 meters per square second to 4 meters per square second. We need to double the force as well, going from 250 newtons to 500 newtons. Okay, well, now it's your turn. You have to solve some exercises by yourself.